do some workouts.
Right. So, okay. Yeah, I already shared one yesterday's video. Okay, and for today I will also be attending, but I got some problem in the net connection. I'm not sure like whether we recorded the
Oh, that is a
interview.
bad luck.
Yeah, but anyways,
Because
I will be sharing all these examples, whatever code we are writing. Okay, and I will
uh,
send some reference to you.
yeah, because video will be very much helpful because whatever we discuss will be able to recollect and
Correct,
at
correct.
least
So basically,
yeah.
yeah. So it was actually I started it when, but because we got disconnect in between, right? I mean, we
Yeah.
started like 1 hour late, so that's where I probably forgot to switch on the video recording.
Okay.
Yeah, so sorry about that, but
Now it is recording, right?
yeah, now I never did. Yes.
Yeah. Okay. No problem. Okay. Thanks.
Oh, so okay. So now we got the idea, right, of how we design the. And if you want to design a specific interface which you want to use in streams, then obviously you
Yeah.
will have to, create something that is actually. So what you can do is, so you can basically extend it, right? So you can define another interface, something of this sort.
Okay.
Okay. So rather than this, you can have is insurance premium, and now this will not be required. So now this you cannot do, but what you can do is, let me, you get my point, right? So you can define a specific type of um, premium calculator which only takes insurance and insurance premium and double, right? But this is probably will not even be needed because uh, the type can be inferred from the context itself.
Okay.
Okay, so I will just revert it back to the previous one so that now coming to the, so we covered these basic, the most important interfaces, right? And we saw where they are actually being utilized. Um, Pipeline you have already seen, okay, but I will explain it more in detail. So pipeline is nothing but it's a chaining of various stream operations, right? I mean, we already saw one example here or the map example, right? So what I'm trying to do is, first I get a stream on which I call a function which actually converts my string to integer. Then I call another function which actually doubles the value of that each element inside that stream, and then I call again another function which again doubles. So what I get is a final value which is 4 times of the previous ones, right? And then I print all the values. So what I'm trying to do is that I'm calling one function at a time and chaining them together, and this becomes my pipeline.
Okay.
Okay, so all the intermediate operations they basically form a pipeline. They take input, they process, and then they return the output to the target.
Okay.
So the output has to be collected by some terminal operation. This is important. So for now, whatever we have been doing, we have been calling for each function, right, which does nothing but just prints the elements, correct? But in some cases, we want to return the result,
Okay.
right? So we say that, okay, give me some result. in the form of a, let's say, a list or whatever, right? So I will have to collect this stream from the pipeline. So let's say I do this public static get 4 times values, and inside this what I do is, so now I want to return the result rather than just printing the items, right? So I will have to call a collect function. Do you see this?
Okay.
So earlier I was calling a terminal function for each, in which I was doing nothing but just printing the elements. But now my objective is that whatever values actually, whatever is the result of this particular pipeline, I want to return this result to my colleague.
Select. Okay.
Okay, so I will have to call this particular function, which is a handy function called dot collect. Inside dot collect, if you see it, it needs a, if you go to the collect, what it needs is a collector. A collector is something that
So,
we get from the collectors.
so it will be a list.
Yes, so there are many useful functions if you see dot collectors, right? So there are many useful functions here in the collectors. One is to list,
Okay.
one is to map, to set, right? To concurrent map or to some arbitrary collection.
Okay. We can convert to any. Okay.
So so this is what the pipeline looks like if you look at it diagrammatically. That there is one transaction, right? So one
Okay.
pipeline basically represents one transaction, and one transaction is a chain of multiple methods. These methods are chained together in order to create the entire pipeline, and then finally results are actually collected. So first function that you saw, on the stream, we are calling it, right? So stream dot filter. So filter will take a predicate. It will give me some result after applying that predicate, and then I will sort it by either by some comparator or by using the natural order of the object, right? And then I will
Okay.
call some other function by calling map, and then finally I will collect the results. So this is my entire pipeline.
Okay.
Okay, and I can have obviously as many number of steps that I want, but this is the way I should be thinking when I'm actually designing my algorithms.
Mm.
Got it?
Okay.
So you understand, right? That when I am writing my program, this is how I have to design. I have to do step by step.
Okay.
So binary version of the interface I showed you, right? That they take multiple arguments rather than single argument, right? So there is a function interface and there is a by function interface.
Mm.
Okay. The only difference is rather than the single argument, they take two arguments.
Okay.
And on the so basically this is what we have already seen, right? Extracting data from an object using map. Stream operation we already seen, right? Some of them at least. Optional class we have not seen. That's something that we will cover in the third class. Okay. Or we can cover it today if you want.
Okay. Sure.
Okay. And lazy processing, right? So this is an important concept, lazy processing, right? So all the so there are two types of operation that we do on streams. One is intermediate operation, one is terminal operation, correct?
Okay.
So filter, map, sorted, all these are intermediate operations, and for each collect, these are terminal operations. So lazy, so
Mm.
all the intermediate operations, they are actually lazy processing. What that means is that nothing happens until you actually call the terminal operation.
Okay.
Okay, let me just elaborate on it a bit more. So I had this premium list, right? Now
Okay.
what I want to do is, on this premium list, I say stream and say filter, right? So I want to filter all the premiums whose amount is more than $1,000. This is what I did.
Okay.
Okay, but when this line actually gets executed, nothing happens. This logic will not run.
Mm.
So what this filter actually returns me is actually the stream. Filtered, sorry. Right. So this is what it will give me. It will return me a stream, correct? But this filter will not
Okay.
run. I mean, it will not incur any programming overhead. This filter will run when we call a for each operation.
Yeah. Okay.
You're getting my point, right?
Yeah. Yeah. Yeah.
So it doesn't matter how expensive this calculation is. It will never incur any overhead until I basically execute the terminal operation, and this is how it is called lazy processing.
Okay. Okay.
Sorting is another operation that you can do on top of streams. We will see some other example of it in the third class. Collect method we have already seen, right? And there are other things that you can do, like you can do grouping. So in the grouping operation, basically it will. So let's say you have insurance premium of many people, right? So you can group them based on some criteria. Let's say by age group.
Okay.
So these are some of the operations, and we'll take up more example later. Now, what I can show you right now is, since we discussed about the optional class, right? So that part also we can cover today, and then in the third class we can see more stream related operation. Okay. So in general, so Java, as had a problem of null pointer, correct?
Mm.
So when you are calling a particular function, just in case that function returns a null object, and you use that, store that in a variable, use that, then you will basically get a null pointer exception at runtime, correct?
Okay.
And this problem was basically so frequent that Java designer said that we have to basically come out with some solution to this, because a lot of programmers are actually facing this problem. So what they did is that they actually adopted this idea from other languages like Scala, and there are other than Scala also there are other languages which actually provide some kind of wrapper on top of the null pointer. Okay, this and so Java has provided a special class called optional, which actually is a container. Okay,
Okay.
okay, and that optional class. So I will tell you what is the signature of that. So let's say my insurance premium calculator. Let's say I was returning something. Okay, public insurance premium get highest premium. Okay, this is generally something I do, right? I run some logic and then I return. Let's say return null. right? Nothing stops
Yeah.
me from doing that. And when I call this function insurance premium calculator, so I am here, get highest premium dot amount. Okay, so I want to print this. Let's say double amount. And when I run this, I should get null pointer exception, correct?
Yeah.
Right. So this is what I got. Can you see?
Yeah.
You saw this, right? Null pointer exception. So in order to avoid this, what Java says that Java 8 has introduced an optional class. So they say that when you are defining your functional, your signature of your function, rather than defining as naked object, what you can do is you can wrap it in optional. Okay. And inside the implementation, what you can do is either you can return an empty or you can return some other. So if you look at this optional class, it has got couple of methods, right? Option
Mm.
one is empty, another one is off, and third one is off nullable. So these are the three major methods, and then we have get. So what happens is that when I am here, I will not get this amount, right? Because I am not getting insurance premium as my signature, right? This object is actually
Mm.
returning me optional of insurance premium, not actually the insurance premium. Now the benefit of this is that optional object will have a method called is present. Okay. So what you can do is the caller of your program now it knows, right? This is actually an optional. It might not have any value at all.
But what is the difference? If we are going for this much big step, then we can have a null check and then do the same
Yes,
thing.
yes, yes. So exactly. You are absolutely right there, right? And that is the argument of many other people also. So the bottom line is this: that when you are returning an object, you are not programmatically notifying the caller of your program that this value can be null also. Primarily, this was done using some description inside the method, right? So in the Java doc, you will write that it may return null also, correct?
Mm.
But programmatically, you are not able to uh, extend this information to the programmer. Now, when you actually deal with the optional, when you are returning optional rather than the actual object, the callee of your programmer will be bit more careful while dealing with those objects because he knows that the value that is actually part of this optional may be even null.
Mm.
So that is the only purpose, according to me, that it actually solves. That in some way it is notifying the programmer that look, it is an optional, it may contain a null value, so be careful when you are calling this code. So in some condition, it is actually returning null.
Okay.
Earlier, it was not possible to communicate this programmatically, but you had to communicate it using English language, right?
Yeah.
So that is the only objective that I believe that it actually achieves. Um, So right. So this is. So do you think that for today we are enough?
Pardon?
I say that. Do you think today we have like covered enough? Should I just check in this code and you will have a look at it?
Okay. Uh, is there anything to cover in this session?
I think for this session, I think we are okay. On the next session that we will start is we will go into more stream related operations. Okay, like grouping we have not seen. That is something that we are going to see in map. Probably we are going to implement some more complex methods. Um,
Can you go back to the previous that uh, slide
which
where
one?
the list uh, not
So I will go one by one. You let me know which one, right?
yeah, this one. Okay. So collect grouping and partition is left.
Correct. So
Then
grouping partition is left.
sorting,
So if you want, we can go through the course content. Okay. So in the course content, we have covered method in reference, correct? And we have done some pipelining as well. We have seen the example. We have explained what pipelining is. We have gone through multiple core interfaces: predicate, consumer, function, and supplier. And we have seen primitive version of these. Simple predicate consumer we have already used multiple times in all the examples. And we also saw the usage of function interface, correct? And binary version
yeah.
is, as I said, is nothing but it takes two parameters rather than one parameter.
Okay. Whether you have the video of the second day of any other classes,
Sorry, I didn't get you.
like uh, if you have taken classes for any other group, and if you have the video, then can you share that? Then I'll be getting the missed the because we started recording from half of our class, right?
Right. So this is what I was trying to. So we covered in the session what we actually plan to do. Probably we could have covered more examples. So that is something we'll
Yeah.
try to cover in the third lecture. Okay.
Okay.
But more
Okay.
and more
Okay.
examples we cover, more and more clarity will be there basically. Because as you saw,
Yeah.
that, there are some confusion that you still have, right? Um,
Yeah.
but the whole concept is that we see more examples, more code, and we understand this streams and lambdas and how to design our program around that, and see some more features of Java, like optional. We have seen some example, but we have not utilized some practical example, right? So that's probably something that we will do in the third class.
Okay.
And optional is basically supposed to be covered in the third one, but we already had a lazy processing basically as again was part of the third class, but we have covered in very brief here. Other things around the streams we will cover in third class and probably try to do like more examples. But real benefit will be when you actually start doing some exercises which I have already shared in the repository.
Oh, okay, okay. No, but what I was asking is like, do you already have videos of other classes that you have taken?
Actually, I
Not for me, any other group.
sorry.
This is your first group, group.
Correct.
Uh,
Correct. This is
where,
this is my first group. Recently, I have some from from my company, but that is something bit confidential, so that I cannot actually share. Um,
oh,
but if you need some explanation around some other thing, then I can take up that as part of the sessions also.
oh, okay, 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 no problem. So is it possible for you to send the videos today, share the videos,
Yes, yes,
first and today's, whatever we recorded?
yes, yes. I will share that. So basically, there is a Dropbox folder which Stream People team has actually shared. I uploaded yesterday's video there, and for today's video also I will upload in that Dropbox. How to get access to that Dropbox? That is something that I do not know right now. Probably. So
No, I have Dropbox, so maybe if you share that link to me, then I can
okay.
uh,
Let me share.
can do the download.
Let me share with you right away.
Yeah.
Okay. Yeah, maybe I can just share with you. Right? That's what I can do.
Yeah, you can. Usually, I used to get from the trainer. Trainer used to.
Okay.
uh, If you have Google, yeah, you have already have. So it's fine.
Which email ID I should share to?
The one which you have sent an mail to me, right? That Dropbox, that is okay.
Okay.
Manjush.kuchi@gmail. Yeah. This will have yesterday's video, right?
Yes.
Okay.
So I already uploaded. So yeah. So did you get email?
Then I have to check. So far, no. Yeah.
Are you able to access?
Yeah. Yes, I can. Yes, I have access. Yeah.
Okay, great. So I will upload today's
Yes.
video also. Okay. So
Yeah.
okay, and you already have access to the repository. Okay. Yes. So you are downloading?
Uh, Actually, I was planning to do that in my Linux one, so I think that will be better
Okay, okay.
because I'm downloading one, but there is no point in downloading it this machine because I'll be working more on that Linux.
Okay, okay, no problem. So, okay, so you can download them, and in the next session when we meet, if you have any doubts, note it down, we'll discuss, right?
Yeah, so you'll be uploading the today's video, right?
Yes, yes, I'll be uploading this.
Yeah, thank you. Thanks a million.
Okay, thank you, Manjush.
Bye. Take care.
See you later then. Okay, bye.